Alrighty, hey there. So I'm going to start off where I left off, which was getting on to 17 of SAT practice test number 4, section 3. Hopefully this video I can finish up this section. So just very briefly, this one's pretty quick. Oops, that's a bad triangle. Let's start that again. Alright, 17. You're given a right triangle, alright? X degrees, Y degrees, right angle. Triangle above, you have sine of X degrees equals 0.6. What is the cosine of Y? Alright, so what you should do here is remember SOHCAHTOA, alright? So let's see, SOHCAHTOA. So sine, right, is opposite divided by hypotenuse, right? This is, so if you're looking at this angle here, this would be the opposite. This would be called the adjacent, and this would be called the hypotenuse. So opposite over hypotenuse, cosine is going to be the adjacent divided by hypotenuse, and then tangent, tan of, say, X degrees, would be the opposite divided by the adjacent length. Opposite divided by adjacent. Okay, and so what it means to have the sine of X be 0.6 is that the opposite, you know, so say you could take, for example, X degrees, the opposite would be 6 inches, the hypotenuse would be 10 inches, okay? And now it asks, what is the cosine of Y? Well, you should ask yourself what that means, right? And so what it's asking for is, what is the ratio of the adjacent side, which is here, divided by the hypotenuse, which is here, and that's just the same thing. So you have 6 divided by 10, which is 0.6. So that's your answer, 0.6. Okay. Now then, let's get on to 18. Oh, this was a fun one. Alrighty, and now you have an equation, x cubed minus 5x squared plus 2x minus 10 equals 0. Okay, I'm pretty sure that the formal solution suggests factoring this or dividing it. If you forget those things, all hope is not lost. I forgot how to do it, and I don't think that you should be forced to remember those ways of doing it. What you should remember is this is a cubic equation, right? It's to the third power, so it's cubic. And what you want to think about is what that looks like, right? So I'm going to draw some graphs of what a cubic equation might look like, all right? Okay, so in general, a cubic equation has this form, right? So a line looks like this, line, quadratic looks like this, or it could be going the other way down, and then a cubic looks like this. Okay, so line has no bends, quadratic has one bend, and a cubic has two bends, right? Inflection points, minima. So what do you want to think about, right? This cubic is, it's going to look generally like that, so it might look like this, it might look like this, and it might look like this, okay? So in this case, what do you want to think about is how many times does it cross the x-axis, right? So here it crosses once, right? It crosses right there. Here it crosses, let's see, 1, 2, 3 times, right? Right there, and right there. And then here it crosses once, right? And there are some, you know, kind of special situations that you can imagine, but basically, you know, you're going to have one of these 3 scenarios, okay? My advice to you is guess and check, all right? That's how you should solve this. So if you do so wisely, you can get there pretty quickly. If you don't notice anything in particular, right, so a good place to start would be, yeah, literally guess and check. So x equals 0. Let's see where that ends up. Okay, x equals 0, that's going to be 0 minus 0 plus 0 minus 10. X equals 0, y equals minus 10. Okay. And you can kind of generally keep track of these things. So let's just make a little plot. All right, so x equals 0, y is minus 10, somewhere down here. All right, well, that's not equal to 0. All right, so what you guess then is y equals minus 10, which is not 0. Okay, so you need to find a place that's going to be on this horizontal line. All right, let's do x equals minus 1. Okay, so this is going to be minus 1 cubed is, oh, there's a different color. X equals minus 1. So that's going to be minus 1, then minus 1 squared is 1 minus 5, so that's going to be minus 5. 2 times minus 1 is minus 2, minus 10 is minus 10. So that's going to be, let's see, minus 18. All right, so minus 1 then would put you somewhere here. Okay, that doesn't seem to be going in the right direction. So let's guess maybe 1 this time. All right, so x equals 1. This is equals y. All right, let's see. So you're going to have 1 minus 5 plus 2 minus 10. That's going to be, let's see, 1 minus 4 minus 2 minus 12. Let's see, did I do that right? Yes, I did. So that is y. So x equals 1. There you go. All right, so from that you can kind of see actually what's going on. You have, so it has to go up at some point over here. Okay. All right, well, let's guess, you know, I mean, if you go really big, say x equals 10, then you're going to have 10 cubed is 1,000 minus, let's see, 5 times 100 is minus 500 plus 20 minus 10. That's going to be 500, 520, 510. That's like way up there, so I can't even draw it. It's really high. All right, so you know that your solution, so the answer, right, let's call that answer, it has to be greater than 1 and less than 10, all right? So let's try 5 maybe, okay? Run out of colors. Let's go x equals 5. Now you're going to get 5 cubed is 125, minus 5 times 25 is 125, plus 2 times 5 is 10, minus 10. That's it. Good, that's 0. That's y. Okay, so there you are. Your answer then would be x equals 5. And you can hunt around to see how you would factor this or do it in a more rigorous way, but really the important thing to know is that cubics have to be of this form, and if you just kind of guess a couple of points, you can get the idea of where things have to be. Guess kind of bigger numbers and narrow down, and then you can get there in, you know, a couple of minutes. Alrighty. Alright, and now let's do 19. Alright, so you're going to have minus 3x plus 4y equals 20, 6x plus 3y equals 15. And it wants to know what is the value of x that that makes this equation to be true. Alright. There's a couple of different ways to approach it, but probably the easiest would be remembering the fact that you can add equations. And so to do that, what you'd want to do is multiply. Let me rate these in 2 different colors. So you're going to have minus 3x plus 4y equals 20. Now let's just take this equation and play with it a little bit. Let's just multiply both sides of the equation by 2, which isn't doing anything. So it'd be minus 6x plus 8y equals 40. It's the same equation, right? Just written differently. And now we can write down the other equation, which was 6x plus 3y equals 15. Okay, so now notice you can, if you were to add these, what would happen? Well, you would add them. Minus 6x plus 6x is going to be 0. 8y plus 3y is going to be 11y. And then 40 plus 15 is going to be 55. So now you get 11y equals 55. So y equals 5. And now you can just plug this back in to say this equation. So then you would get 6x plus 15 equals 15, 6x equals 0, and you actually get that x equals 0. So that's your answer, and you can check that back in this equation. It's always a good idea, or this one if you prefer. So that would be minus 3 times 0 is 0, plus 4 times 5 is 20, equals 20. Good, okay. All right, so on to the last one. Alrighty, so 20, sorry about that. All right, mesosphere is a layer of the Earth's atmosphere between 50, all right, so 50 and 85 kilometers. Here's Earth down here, all right. Mesosphere, meso, right, just in the middle. So at a distance 50 kilometers from the Earth's surface, the temperature is minus 5 degrees Celsius. And at a distance 80 kilometers from the surface, temperature, so let's draw another line, 80 km, it's going to be minus 80 degrees Celsius, okay? And it says for every additional 10 kilometers from the Earth's surface, the temperature in the mesosphere decreases by k degrees Celsius, where k is a constant. All right, Earth. So basically, what you have is at 50. So we're going to make another chart: distance and temp. Okay. This is going to be in kilometers, and this is going to be in degrees Celsius. Okay, so this is 50, 60, 70, 80, and we're given that at 50 kilometers, it's at minus 5, and at 80 kilometers, it's at minus 80 degrees Celsius. And so it's just going to increase by a constant amount. So for example, if it increased by, if the temperature dropped by 5 degrees Celsius every 10 kilometers, then this would be, minus 5 degrees C, minus 10 degrees C, minus 15 degrees C, and minus 20 degrees C. All right, so you know that the temperature drop, which is K, what is the constant amount that it drops? It's going to be more than a 5-degree change, okay? And the way to calculate it is just this difference here, right? It's going to be 80 minus 50, it's going to be 30 km. And then the temperature change is going to be minus 80 minus 5, which is going to be, it's a temperature change of 75 degrees, and it just happens to be a negative temperature change, right? So if you wanted to get the average change, what you do is just 75 degrees Celsius divided by 30 kilometers, right? Is going to be, 75 divided by 3 is going to be 25 degrees Celsius per 10 kilometers, right? And so that's actually what it's asking for. And so what the constant K then is 25 degrees C. Okay. All right, so that wraps up this section. I will be making another video that will go over section 4, which is the calculator section of it. I'll make a couple of videos on that, and I hope that it's helpful to you.